So we have a problem here, linked list cycle. Here we have to detect whether the given linked list is having a cycle or not. Suppose here we have 3204. Let me explain here. Okay. Suppose we have 3204, and then if there is a link between this 4 and 2, then we say that our linked list is having a cycle. Why? Because this 2 can be accessed repetitively if we point the next reference of each node every time. For example, if correctly head is pointing to 3, then next reference will point to 2, then 0, then 4, and then again 2, then again 0, then 4, then again 2. So this is a pattern of cycle. So if we have a cycle, then we will print true. If we do not have cycle, then we will print false. When we will do not have a cycle, when we will have a null reference to any node. For example, null reference to 4 node. If at any point of time we are getting this null difference, then we will return false. That means there is no any node in this cycle which can be accessed repetitively. Suppose if we have a single node, suppose 3, and 3 is pointing to itself. And then here also we see that always 3 is pointing to itself only. Okay. And there is no any chance of null node, null node where 3 is pointing to null node or not. There is no any chance of it. So this is in this case we will return true. Okay. So what is the idea here? So we will apply the idea of Floyd cycle finding algorithm, where we assume two pointers. First is fast and then slow. Okay. Let us see with the example of 3, 2, 0, and then 4. Suppose 4 is pointing to 2. Initially, the fast and slow will both will point to 3 only. Okay, and then we will move the fast pointer one step ahead of slow. For example, if fast is initially at 3, after that the fast will point to 0, and then slow will point to 2. Okay, again the fast will point to 1 ahead. That means next dot next. So fast will come here and slow will come here. Okay, similarly, fast will go 1 ahead of slow, fast will come here, and slow will come here. So if there is any cycle in our algorithm, then it is for there is for sure that fast and slow will eventually catch up with each other. So if fast and slow will become equal, or if fast or slow will point to the same node, then we will say that the linked list is having a cycle. If fast and slow is not catching or not pointing to the same node, then we will say that linked list is not having a cycle. How can I say it more confidently? So suppose 3, 2, 0, and 4 is not having a cycle. Initially, fast is here, slow is here. So fast will move two step ahead. So fast will point here and slow will point here. Now fast will point null and slow will point null. So you see, the fast will never be able to catch up this slow. Okay, if there is no any cycle in the linked list. But if there is a cycle in the linked list, whatsoever be the number of iteration, eventually it will catch up slow, resulting in fast is equal to slow. So this is the Floyd cycle finding algorithm. Now we will code it down. Okay. I will use Java for it. Let us make a list node. First fast. Let us point it to head, and then slow. Same. We will point it to head. We will create a while loop. Now initially, uh, uh, what we'll do is we'll see if our fast is not equal to null, and also fast dot next is not equal to null. Okay, why I'm writing this? Uh, we'll run this loop at that time when this both conditions are true. If any one is false, then we will come out of the loop. When we will come out of the loop, when we will get a null difference, and whenever we will get null difference, we will actually return false. Okay. Now inside this while loop, what I'm going to do, I'm going to write a condition when this fast and slow will catch up each other, and when they both will catch. to each other, then we will return true. Now for that, first of all, we'll iterate. Okay. So fast, sorry, is equal to fast dot next two times. Okay. And slow is equal to slow dot only one time. Okay. And then we will give a condition if fast is equal to slow, then just return true. Simple. And then if they are not equal, then return false. I think we are done. Let's check. Test case is done. Accepted. Good time. Memory also quite nice. It can be optimized, I believe. But if I try to optimize this memory, then it can happen only at the cost of memory, which at the cost of time, which I do not want, because we always try to minimize this runtime. Okay. Thank you.